Hey y'all. I'm just getting rid of some of these things. All right, today's lesson is called Constant Rate of Change. And you have your note outline, and we are starting a new chapter. So, constant rate of change, let's get some vocabulary first. A linear relationship is any graph that has a straight line. Maybe you see the root word of linear is the word line. So a straight line could be vertical or horizontal, but also diagonal is going to be considered a straight line. So a linear relationship is one that forms a line between the two quantities or the two items being compared. And if the graph, I got to turn that focus off. Sorry about that. I saw it focus. Okay. There. So a linear relationship is formed when the two quantities are compared and they form a straight line. Before we talk about constant rate of change, the rate is like the speed. So how fast or slow something changes. Okay, how fast or slow two things change, because we're always going to be comparing two items or two quantities, one along the x-axis and one along the y-axis. Who is that? Ren, please go. I'm recording, and this is really distracting.
I just came out.
Sorry.
Okay, get outside. I came out.
They're getting fussed. How fast or slow two things change. Now, a constant rate of change is when the rate of change is the same. Constant means the rate of change is the same each time. So, for example, if you were driving in a car on the highway and your mom or dad or whoever's driving puts on their cruise control and they set it to 65, that means they were having a constant rate of change. They're constantly going 65 miles per hour. 65, 65, 65. But if you took an exit and you were along like just a regular road and you came to a stoplight, well, you would slow down, and then when the light turned green, you would go faster, and then you would drive, and you'd probably slow down again, and that would not be a constant rate of change. It would still be rates of change because your rate is changing depending on where you're driving, but not constant. And so today we're going to talk primarily about constant rates of change. Here's an example. The time to download songs... my table's sticky. Here is a table. So the time to download songs, the time is your X value, so that would be your X axis, and the number of songs that you can download is your Y variable, and that would be your Y axis. So if you have 0 minutes, then you can only download 0 songs. That should make sense. 1 minute will download 2 songs, 2 minutes will download 4, and then so on. So we're going to graph these, and we're going to show you first that it's linear. 0, 0 is your first ordered pair. Your second ordered pair is 1, 2, because it's the 1 is the X and 2 is the Y. And then 2, 4, 3, 6, 4, 8. And as you can see, these continue in a straight line. Now you don't have to connect them. I'm not saying connect them. I was just showing you it's a straight line. It's diagonal. Now, how long will it take to download 9 songs? 9 songs. Well, you could look at our graph, 9 songs, this is the y-axis, 9 songs would be here, so it's going to be kind of in the middle of 4 minutes and 5 minutes. So 4.5 minutes, 4.5 or 4.5 minutes. So this is just an example of a linear relationship, and you were given the table. So in the next one, I'm going to show you actually how to find the rate of change, but you might be able to tell and the rate of change for this one, how fast or how slow are you downloading songs? I'll just go ahead and tell you. The rate of change is going to be the change in Y over the change in X. So the triangles mean delta. That's a Greek letter, and it also means change in math. Delta means change. So the change, the delta, the change in Y over the change in X. And if you aren't sure, that means you're going to subtract. So again, it changed. It went up 2 songs. Do you see how it's plus 2, plus 2, plus 2, plus 2? So it went up 2 songs. That's the change in y over the change in x. In the x table, it went up by 1 minute. So my rate of change is 2 songs per 1 minute. And that is my rate of change. This is a constant rate of change because it's linear, and that means it goes up 2, 1 every time. Up 2 over 1, up 2 over 1. But the rate of change, like the correct answer would be 2 songs per minute. The change in y over the change in x. All right, so let's practice another one. The number of gallons of water remaining in a fish tank over time is shown. So the amount of water in a fish tank. Is the relationship between the number of gallons and the number of minutes linear? Is it linear? If so, determine the constant rate of change. That's how we can tell if it's linear. It doesn't have a constant rate of change. So to find the rate of change, we need the change in y over the change in x. The change in y over the change in x, which means we need to subtract what's happening. So the change in y, so from 86, and then we take away 102. Well, we know it's going to be negative something. So that would be 12. So negative 16. And then from here to here, 8 minus 6 is 2. So you always like subtract back to figure out what the change is. So 102 minus 118. 102 minus 118 would be negative 16. And 6 minus 4 is 2. 118 minus 134. I'm just going to do that one over here. Let's see. 12. 14 minus 8 is 6. 12, or 2 minus 1 is 1. So 16. So again, negative 16. And then 4 minus 2 is 2. So my change in y's were constant. Negative 16, negative 16, negative 16. And my change in x's were 2, 2, 2. So again, to find the rate of change, it's the change in y values. So this is your y over the change in x values. That is your rate of change. And again, the y in this instance is the water. So negative 16 gallons of water. Now, because it's negative, that means we must be losing water. And then you want to reduce negative 8 over 16. I mean, negative 16 over 2 is negative 8. So negative 8 gallons per minute. That is my rate of change, and it is constant because it's always the same rate, the same constant rate. So it is linear because the rate of change is constant. So that would be your answer. Is it linear? Yes, because the rate of change is constant, or the constant rate of change is negative 8 gallons per minute. All right, so let's do some more. These are you tries, but I'm just going to do them with you. Is the relationship linear? If so, determine the constant rate of change. If not, explain your reasoning. So in you try 1, a hot air balloon descent. So the word descent means it's going down, so we should expect negatives. So I'm going to subtract 40 minus 30 is 10. 30 minus 20 is 10. 20 minus 10 is 10. So it looks like on the x, and remember these are the x and these are the y's. It looks like on the x, these are all going to be increasing by 10. And now these are decreasing, so I should have negative numbers. So 99 minus 123 would be negative 24. 123 minus 143, so that would be negative 20. And 143 minus 165 would be, let's see. Oh, wait. 165 minus 143, 2, negative 22. So you should be able to see, oh, these are not changing at a constant rate. They're changing at rates, but they're not constant. See, I have a negative 22 over 10, negative 20 over 10, and negative 24 over 10. So is this relationship linear? The answer is no, not constant rate of change. There's not a constant rate of change, so that means they are not linear. All right, you try 2. Is this relationship linear? It looks like it is linear. but let's just check it just to make sure. So this point right here is 8, what is this? 30, 40, 50, 60, 70, 80. So is this 80 or is this 70? So I think this is 40, 50, 60, 70, 80. So I think that's 870. And this is 16. Oh, no. That's 80. And this is 1660. And this is 2440. Right? 40, 50, 60, 70, 80. So now let's check the rate of change. It's the change in y over the change in x. So you can see it's going down. So again, we're going to have some different, so we're going to have negative. 80 to 60 is a negative 20. And 8 to 16 is a positive 8. So that's one rate of change. Now let's go from this middle dot to this third dot. So I went from 60 to 40. I'm looking at the change. How much did the y's change? And from 60 to 40, it went down 20. But the x values from 16 to 24, it went up 8. So it looks like this is linear. Yes, linear, because a constant rate of change. And the rate of change is negative 20 over 8, which reduces to negative 10 over 4, which is negative 5 over 2. And that means that we need to put some units with it. Negative 5 is the y's. Right? So it is every decrease 5 minutes, number of volunteers, and the time. So as the time decreases, the number of volunteers increases. So that means every 5 minutes that we go down, and I got that because it started with negative 20 over 8, and it reduced to negative 5 over 2. So every 5 minutes, as the time goes down by 5 minutes, the volunteers will increase 2 each time. Okay? So here we go. On the back. Proportional linear relationships. We know how to check if a relationship has a constant rate of change to see if it's linear. A relationship between two quantities can also be proportional if the ratios are the same. So the ratio of y to x, not the change in y, the change in x. The constant rate of change is the change in y over the change in x. But if we want to see if it's proportional, we just check the ratio. And then it says right here, compare the ratio for several pairs of points. So let me show you how to do that. Determine if there is a proportional linear relationship between the number of hours you rent a cotton candy machine and the total cost of renting the machine. So we need to find out if the rate of change is constant and if the ratio is also the same. So first let's talk about the rate of change. The change in y's over the change in x. And the hours we rent are our x variable and the cost is our y variable. So it looks like this is changing by 3's. And 85 minus 70 is 15. 70 minus 55 is 15. 15, 15. So the change in y's over the change in x. So all the y variables are changing by 15. And all the x variables are increasing by 3. Which means 15 over 3 reduces to 5. So my constant, or my rate of change is $5, because the y value is on top, $5 per hour. That's my rate of change, and it's constant, so that means it's linear. Now we need to check the ratios to check if it's proportional. And the way you check the ratio is you just set up a ratio of the y variable to the x variable. All right? The y variable to the x variable, 55, 6, 70, 9, 85, 12. And you don't want to start with that first one because you can't divide by 0. So if you are looking at this, this one's kind of easy to check. 3 times 2 is 6. And so if these were equivalent, if these were equal, 3 times 2 is 6, 40 times 2 would be 80. And so these are not equivalent. And then you could do the same thing. So is it proportional? And the answer is not proportional because my ratios are not equal either. Okay, so your ratios have to be equal and you have to have a constant rate of change. You can also check the graph to see if it's proportional. So we have a graph of the information, the cost of the cotton candy machine, and you can see the points plotted just up here, 0.25, 3.40. It is linear, just like we determined. It is linear. But, do you see that right there? In order to be proportional, must go through the origin. Write that down. Does this graph go through the origin? It does not. So this is not proportional because it doesn't go through the origin. In order for it to be proportional, it has to go through the origin of the graph. And then it has to be linear. So you can tell by the graph as well. Or you can check the ratios. All right, so you have this U-try. Use the table to determine if there's proportional linear relationship between the mass of an object in kilograms and the weight of the object in pounds. So we need to check the rate of change and the ratio. The rate of change is the change in y over the change in x. So I'm going to subtract. 36 minus 27 is 9. 27 minus 18 is 9. 18 minus 9 is 9. 80 minus 60 is 20. 20 minus 40 is 20. 60 minus 40 is 20. And 40 minus 20 is 20. So my change in y's are 9. And my change in x's are 20. And can you reduce that? No. So that is a constant rate of change because for every 9 kilograms, increase by 20 pounds. And the reason I know it's increasing is because the numbers are getting bigger. So that is my rate of change. Make sure you write that statement. The rate of change is always going to have like units with it. So now let's just check our ratios, y over x. So 36 over 80, 27 over 60, 18 over 40, and 9 over 20. So I'm going to check my ratios. I'm going to see, can I reduce? So I can't reduce 9 over 20, but I can reduce this to 9 over 20 because I can divide them both by 2. I can divide these by 3 and I get 9 over 20. And I can divide these by 4 and I get 9 over 20. So you see all the ratios are also constant, which means it is, yes, proportional. So this problem, this example would be linear and proportional. And if you graphed it, it would go through the origin and it would be increasing. All right, so we'll practice more with constant rate of change and proportional relationships in class.